Hi everybody, welcome to the second video from the series AI Lessons from Spam Detection, and today we are going to talk about the topic why phishing detection is extremely hard. So let's start with an example. Most of you have probably seen this kind of similar example in your email inbox. Here, for example, the user has received an email from PayPal saying that there is a new signing attempt in the PayPal account from a new device, and PayPal wants them to review the activity. And to be frank, this kind of email are not very convenient to see. And since this is from PayPal, you are a little bit more concerned. The logo looks intact, the wordings are very professional, and there is a button says secure my account. But the uncomfortable truth is that this email could be very well be real. And because PayPal asks you to verify your logins, and these emails have become part of our life. So whether you should click on this button depends on some factors, and we will check on those factors shortly. So let's try to understand what exactly is phishing. So phishing is a type of a cyber attack where an attacker pretends to be someone you trust, and they expect you to take some actions that is going to benefit them. The attacker goal is to make you do something like clicking a link, enter a password, share a verification code, for example, or approve a payment or give some personal or financial information to them. So the attacker creates a message that looks trustworthy. It, they even add pressure or urgency to the message so that you would act to it even thinking carefully. Therefore, if you look at this pattern, it's more of attacking the user's trust, and therefore detecting it is pretty hard. And since now we know about phishing, let's dive deep into the topic. So phishing is not just content detection, it's more about intent detection. So the text might look very normal, but the idea or the intent behind it may be malicious. So suppose you receive two different emails, email A and email B. Email A says your account password will expire today. Click here to reset it. Email B also says the same, your account password will expire today. Click here to reset it. But email A has been sent from your IT system provider, and email B is coming from an attacker. Now, if you pause here and think for a little while, from the user's perspective, these both email look the same. But from the detector or the phishing detector's point of view, the text alone is not enough to judge this email. And therefore, the phishing detector or the system needs to understand the intent behind this email. So, how does a detector detect intent? To detect intent, you need to detect the context. And to detect context, you need to analyze some kind of the signals that come around with this email. For example, who is the sender? Where does the link in the email lead to? Was this email kind of expected? Does this email go into some kind of fake login page? What does it ask the user to do? And are there any known patterns in previous phishing attempts that this email could be mapped to? And even then, it may not be obvious because these attackers kind of are very smart. So they design their emails that are not clearly safe or not clearly malicious, just believable enough. And at this point, you might ask, why not build a filter that blocks every suspicious email? Or why not block every password reset emails? Why not block any emails that has the word urgent in it, right? That kind of sounds safe, right? But in practice, this would kind of break the internet because real life depends on this email. You cannot simply block all password reset emails or bank alerts, right? Imagine an university acceptance gets blocked because the phishing detector thinks it's a phishing email, or a job interview gets blocked because it kind of detects it's a phishing attempt. So these are false positives, and false positives can be costly. And on the opposite side, you cannot have this filter too relaxed, so more phishing gets through and more user gets scammed. And so therefore the goal is not just to block bad emails, it is also avoiding blocking good ones. So let's talk about some real world phishing attacks. And I wanted to present before you two attacks where it had two different type of damages. One was direct financial loss, and another was downstream user impact. I also wanted to keep it like short and not go in much detail about it. So in 2024, the Pepco Group and its Hungarian business was hit by a so-called sophisticated fraudulent phishing attack, and the result was a direct loss of 15.5 million euros in cash. And even though they didn't publicly explain how the phishing attack happened, but the goal was basically to make the employees believe that the payment instruction was real. And in the second example, Twilio suffered a attack over SMS where the attacker created a fake login and stole credentials of thousands of Signal users, because Signal users were dependent on Twilio's phone verification facility. So now let's look on the other side. So far we saw how AI is helping creating better phishing emails, but can AI also help creating better defense systems? The answer is obviously yes. And the most useful case of AI would be when it could combine a lot of weak signals than just one obvious red flag. So we could use a lot of weak signals together to reveal the pattern, and we could see a lot of weak signals coming from an email before branding it as a phishing. For example, does the email has a lot of urgency or a fear, or does the email try to impersonate somebody, or do they use some lookalike domains or redirects? Does this email try to fake login visual similarity of some known domain, or is it an unknown login or a request? And this is where AI would be useful, because when there is no single red flag, you can combine a lot of weak signals to decide whether this email is a phishing or not. And in my opinion, a good AI should also reveal why you made that decision. So, for example, if you flagged an email as phishing, you could tell the user that you have flagged this email because the domain is unusual, or the link imitates a login page, or it creates an urgent pressure, for example. And in my opinion, this is important because it kind of builds trust among the users, and it also helps users learn about phishing attacks. Because blocked is useful, explanation is even better. And even if you have like a pretty good detector, there will be always some emails that would be a miss, right? So those would be your false negatives. And in the end, and human would obviously or probably make better phishing decisions compared to an AI system, and therefore human decisions would still matter. So, what can we as humans do to save ourselves from phishing attack? The safest habit is obviously verification. However, if I just tell you that please don't click any suspicious link, this kind of sounds very vague, because most successful phishing attacks are the ones that are not vague, right? So the better rule is to slow down when asked to act. And the reason behind is because most of the phishing emails would want you to do something on that email. For example, they want you to click a link, open an attachment, reset your password, scan a QR code, etc. So before asking, does this email look real, you could ask the question, what is this email asking me to do? And the answer to that question quickly changes how you think. For example, you could receive an email saying somebody has tried to log into your PayPal account, right? And obviously your instinct is to do that, to reset your password quickly, or save your account quickly. But that exactly is what the attacker wants you to do. So you could basically slow down and check for different signs that comes around the email. For example, uh, is the email coming from a lookalike domain? So you could uh, check the domain of that email carefully, right, and see that whether it is coming from PayPal, or is it coming from PayPal-support.com. So do you know the domain PayPal-support.com as a PayPal legitimate domain? So that would kind of answer your question whether this email is valid or not. The second thing that you could do is you do not trust the button text there, right? So for example, here is the secure account. So you would instead look at the link that this email is trying to point you to go to, right? You could also open the official app and do that thing there instead of just looking at clicking at that email. And if you receive something at your work, it's the safest thing is to just not to just ignore that email, but to report that to your IT or somebody. The major point here is that you don't let the email control you, but you control the process around it. So how is the future of AI phishing going to look like? So with this advanced GPT and cloud models, along with all the diffusion and deepfakes that is available, the future of AI phishing may not just be limited to emails. In fact, it would probably be more like a conversation. And the attackers are probably going to hyper personalize it based on the victim. So they would use all the public information that is available, for example, jobs, posts, even scanning the networks, and copy the writing style just to lure the victim into the trap. For example, if you see a message something like this, and you had recently made a talk about a recent project that you did, and the attacker says, "Hi, I saw your recent project. Could you review this speaker agreement before tomorrow?" And reading this message, this seems very personal, right? And because it connects to something real, you're more likely to trust it, and therefore you're more likely to fall into the trap. The second thing is the attackers are going to use multiple channels. For example, first you'll get an email, then you get a LinkedIn message, then you probably get a calendar invite, and then a personal phone call. And each step is supporting the previous step. So the attacker is trying to build a story around it. And with multiple channels involved, this kind of feels more and more real. So what's the final takeaway from all this? So phishing attacks trust, and that is why it is extremely hard to detect. And since it is attacking trust, it's not always looking like a scam and more like a normal life. For example, your regular bank alert, your regular delivery update, your password change, etc. And this means it's just not about links, it's about deception inside the trusted systems. AI can definitely help defenders to find suspicious patterns, but AI also lacks the context around it, and therefore, we as humans can also help by first slowing down and verify important information outside the email. Our attackers will keep adapting. And the future may not be just like an email, it may be a voice, a face, a conversation, a complete story. So the final takeaway is that phishing detection is not just about finding fake emails, it is about detecting deception inside things that we already trust. And therefore, it becomes one of the hardest problems in cybersecurity. More importantly, detecting deception is harder than detecting spam. That's it from this video. If you found this content useful, please don't forget to subscribe to the channel and share with your coworkers and friends who might find this content useful. I will see you in the next video. Thanks for watching.